coast at Ōpunake. And Shane, we've got pretty much the story of Taranaki right in front of us here.
Yeah, we're actually in an old river valley, so it doesn't seem like we're in an old river valley because it's all been filled up with these sediments. So these are Lahar deposits, and a Lahar is generated on any mountain volcano, simply if you've got a crater lake like on Ruapehu, or if you've got any volcanic ash that falls on the slopes, and it always rains. So Taranaki has something like 15 metres of rain per year. And you have a rainstorm, all the fresh volcanic ash on the slopes, it sweeps down and creates these big floods with lots of rock particles mixed up with water. And so this is a Lahar deposit. This one's sort of a little coarser, it's got these sort of angular looking particles in there, slightly different colours and so on. And we've also got some finer grained units here. So the key thing about Lahar deposits is they generally produce these nice flat lying beds. And so across the landscape, nice smooth surfaces produced by lahars.
Okay, so that's what a lahar is, and you said all the rainfall that we get in Taranaki means that they're a big risk, quite common, but not as devastating as the likes of the debris avalanche that you told us about before.
Yeah, they're definitely not as devastating because the debris avalanche just sweeps across the whole landscape, whereas the lahar sticks within the main river channel. But the lahars are more dangerous than floods. So a flood is mainly just water, and so it can flow around underneath bridges. Sometimes some trees can get blocked up under bridges. But lahar's got this half mixture of water and half of rock particles, sweeps everything out of the way, so you will destroy bridges. So that's why they're very dangerous.
Right. And you were digging down here before. What have you got there to show us?
Oh, that's a little secret. We'll just come down here for a little deeper. So we have been here before, so we kind of know what we're looking for. But here we've got all this Taranaki Lahar deposits and so on, and we don't know how old they are necessarily when we first come to a place, and so we want to figure out how old they are. Sometimes we can use radiocarbon dating, but another way to figure out the age of things is to look for ash layers that we know the age from other volcanoes. And here we've got an ash layer, this white area here, which is actually from Taupo volcano, and it erupted around 25,000 years ago. So we know that this is about 25,000 years ago, and so we can start piecing together our story of the filling in of this big river valley.
And interestingly, Shane, you were telling me that you found ash from Taranaki in Auckland.
Yeah, so just like finding ash from Taupo here, we can actually find ash from Taranaki all across the North Island. And so basically the winds mainly come from the southwest or the west. They get blown all the way to the east or northeast. So we know something like 230 eruptions produced ash layers within lake and swamp cores all around the Taranaki region. And something like 50 or 60 of them made their way all the way up to Auckland. We also find them in the Hawke's Bay and the Gisborne area.
Right, so something that we need to be prepared with in terms of eruptions in the future, the vast areas that the ash could affect. Isn't it fascinating being able to be a bit of a detective in a rock outcrop like this? Thank you, Shane.
Yep, just using your eyes and understanding. Obviously, we've had to do a bit of chemistry to make sure that that was the right one. But essentially, you're looking at lahars, super common, super frequent. They affect your waterways and rivers. And the ashfall, which then is dispersed much further from the volcano. The two most common hazards.
Right.
Mm.
Kia ora.